Hi. That's a six-step process in any statistical analysis lifecycle. So, to elaborate on the six-step process, the very first thing is when you are starting a statistical analysis project, you need to have an understanding of data and business surrounding it. That is the very first step that you do. You understand your data and also the business surrounding it on how the data is generated, right? That is the first part of it. The second part is how the data is being collected today. Now, the data can be collected using some online survey or field survey, or the data can be naturally generated by your business. It can be your transaction data of a credit card transaction, or it can be an customer transaction data of a retail industry, right? So we need to understand how the data is being collected. That is the second step. Now, the third step is when you're getting the data from any of your system of records or even from surveys, you need to understand whether the data is raw or the data is summarized data, right? You need to understand whether the data is data that is coming to you is as in its natural format, or somebody intermediately has summarized the data and given it to you. And typically when you're getting the data from your data warehouses, you may end up with summarized data in many cases. That is the third part. The fourth is, now if the data is summarized, you need to understand the lineage of the data. You need to understand the process that has gone through for the summarized data. Basically, you're understanding how the data is getting summarized. That is the fourth point. Now, once you have this first four set of process and understanding, then you go to your fifth step where you understand your distribution of your data and the nature of your data. So this is where your descriptive statistics comes into play. And once you have the distribution and understanding of your data, you then go and analyze the data and draw conclusions from it, right? And this is where your inferential statistics come into play. So this is typically a six-step process in your statistical life cycle. Now, what I'm going to do in this video is we are going to prepare a data set that we will use it in our feature video. So we will use it to define some statistical functions out of the data. And as we go in, I will tell you why I'm creating this data set, right? Not only we are going to prepare a data set, but also we are going to understand the business process behind the data. And also we are going to see some interesting facts about the business process. Basically, the final data that we are going to use will have a lot of KPIs of the business that we are talking about. And the business we are going to talk about it, credit financing or credit lending. So let's get started. I will go into the details of the business process as we go into the data set. So the very first thing I'm doing is I am importing pandas and numpy, and I'm importing some visualization libraries. That's what I'm doing over here. So let me run this. The data set that I'm going to use is Lending Club data set that is available in Kaggle. But the data is pretty big. It's around 1.3 GB, and I cannot load it in my GitHub repo. You can download it by Kaggle. What I've done is I loaded into my Collab drive. So the Google Drive rather. So what I'm doing is I'm mounting my Google Drive over here. You can see over here, I'm calling that Google Colab import drive, and I'm mounting the drive over here. So once I run it, it will mount the drive. If you are mounting it for the first time, then it will ask you to click a link and authenticate with your Gmail ID and give you a code. You need to enter it, but I've already done that. So I'm just mounting the drive here, and I'm going into my drive data sets directly to see what are all data sets that are available. And the data set I'm going to use the loan analysis.csv, which is around 162 MB. Now the real data is 1.3 GB. I have cut short some columns and taken some selected columns that I'm going to use. So that's why it's around 162 MB. But even if you run with the full data set that is available in Kaggle, the notebook will still work. Now the next thing I'm doing is I am reading the dataset loan analysis using the pandas read CSV method, and I'm assigning it to a data frame, the loan data frame. Now this data set is very big. It's around like close to 1 million. Let me print the number of rows. I'm just doing a shape 0, which will print the number of rows. If you see, that is around 1 million plus record over here. And typically for a visualization or statistical inference, the data set is pretty large, right? And I will show you like why it is large as we go in. So we might want to kind of summarize the data in a way that we can do some analysis, and we may be able to answer some business question regarding this business function. I will go to the question in my next video where I am going to talk about some statistical function, but now I'm just going to go through the business process and what summaries I am creating I'm going to show you. So let me quickly print the first few records. And if you see over here, there's an ID, which is nothing but a unique identifier. That typically in a credit lending process, you will have an loan amount, you will have an interest rate, you will have the installment, the monthly installment that particular customer is paying. You grade a loan, whether the loan is a good loan or riskier loan. So you do a lot of grading of the loan, the title of the person. So there are a lot of columns over here. The main column is the annual income. Basically, how much is the customer earning? So accordingly, you can price your loan. That is the main column. The loan status says whether the customer has fully paid, whether the loan is current, or whether the loan is in default status or charge off status, right? Whether it's a good loan or bad loan, right? The DTI is one column which we are going to use. The DTI is nothing but debt to income ratio. So in any credit lending process, what you do is when you give a loan, you are checking whether what is his debt. That if he's looking for a 10,000 loan and his income is around like 100,000, then basically his debt to income ratio is 10%, right? You are just checking what is the debt to income ratio. And typically bank typically do not go more than 40% maximum. Typically they like it to be in the 20 to 30% range, but they don't go more than 40%. If somebody has already taken an debt of 40% of his income, then his loan can turn out to be risky. So this is one key column that we will be using. Then there are other columns like FICO score. Now, when we submit an application, the application is approved or rejected based on the credit score of the customer, plus other parameters like annual income and whatever documentation the banks are asking. But this FICO score, the FICO range over here, is a key variable that determines it. Now, FICO is basically a method of quantifying and evaluating an individual's credit worthiness. So if he has like an high FICO score, that means his credit worthiness is high, so he may repay the loan. If it is pretty low, then it's a highly riskier loan. So this FICO score ranges between around 300 to 850. In general, any kind of number above 650, right? But now 300 to 850 the range. Any range above 650, it indicates that the person has a good credit history, and less than that, typically it's a subprime loan. Now some banks typically give you loan based on your FICO score more than 650. They don't even entertain customer which has less than 650 or 600 or whatever threshold they set. But there are some subprime lending companies where they give loan to less credit score customer, but at the same time they charge high interest rate. So your interest rate also depends on your FICO score, right? So that's what it is. And this FICO score takes into consideration a lot of parameter. It takes into consideration your payment history, whether you are paid your historical debt in proper interval or you have delayed the payment, how many open accounts you what is your current basic delinquency rate, if have you started delinquent in some other account. So they are aggregator who take into consideration all the parameters to come up at the score. So this is the key variable that we'll be using. And when it comes to the credit score, this is a very key variable. So all the summaries we'll be creating is based on the FICO score, right? Now that is one variable that we will be using. There are two things. There's a FICO score range and last FICO score. So basically, when you underwrite a customer when he's taking a loan, you will capture what the FICO score is. But over the time, the customer may be opening a lot of accounts or may not be paying, and his FICO score might come down. So this is the last FICO score. You keep on frequently evaluating the customer to see what is his current FICO score, whether he might turn risky. That's where the credit risk modeling come into play, right? So you also collect about the latest FICO score of that particular customer. Then you have whether the customer is an individual or joint applicant. If he is a joint applicant, then the annual income of the joint applicant, right? So basically, that's what here. What is the total annual income of them, and whether it's a joint loan, then what is the debt to income ratio joint? So when say I have like two people in the loan, if I only underwrite the customer based on primary loan, and the second person has maybe like 60% debt out of his income, then it can be risky as well. So you need to understand what is the joint debt to income ratio and the annual income to underwrite a loan. So these are the different variables variables, and the data set is pulled by a company provided by a company called Lending Club. Now, Lending Club is a peer-to-peer lending. So, what is a peer-to-peer lending? So, peer-to-peer lending is basically, you can treat it as an exchange for providing loans, where the borrowers can create like unsecured loan up to $40,000, and there are investors on the other end. The investors can be you, me, or anyone else who can search for a list of loan and say like they can fund the loan. Now, when they fund the loan, they typically get a good interest rate compared to the savings bank account. But you can also select what loan you want to fund. You want to fund a highly kind of high risk loan or a low risk loan, and accordingly your interest percentage varies. You may even get like 15% interest or 6% interest depending on the riskiness of the customer. That is Lending Club. So this is about the data set. This is about the business. Now I can take this data and I can create my statistical function. Right now, let me see what is the problem with that. Right, so now if you see on the top, it had 1 million rows. So what I'm going to do is I'm going to take the only 100 records of this particular data set, and then I am going to create y-axis on interest rate and x-axis as FICO score, and I'm going to create a regression plot. Right, when I run this with only 100 records, I am fine, like I'm able to see some pattern. But when I increase it to 1,000 records, if you see, like it's getting noisier, I am not able to infer anything. One thing I can see is, okay, as the FICO score is higher, the interest rate is lower. Right, because more the FICO score, the customer is less risky, so the interest rate will be lower. But if I go to 10,000 records, it becomes even noisier. So basically, I cannot work with such high data set. I can sample it, but sometimes when I sample it, I may have some kind of sampling bias as well. Rather, when I'm creating some statistical function or I want to answer some business questions, let me try to summarize this data with various metrics, and that's what I'm going to do from here on. So let's get started with that. So the very first thing, I'm checking the target variable loan status. I'm checking what are the different loan status available. Right, this is going to be my target variable as well. Now, if you see here, there's a fully paid, there's a current. Fully paid is the customer who are already paid off the loan and they are done with it. The current is the customer whose payment is still going on, but the account is in good standing. Charged off is the customer who did not pay the loan and their accounts were like charged off, written off. There are customers who are late 31 to 120 days. There are customers who are in the grace period. There will be always 15 days grace period after the last date. And then there will be like 16 to 30 days customer are late, and customer has defaulted. The customer has defaulted, but still like the company is trying to go to the collection departments and collect the loan. Rather, it's not completely charged off it. So these are the different targets available. Now, what I'm going to do is I'm just going to use fully paid and basically the charged off and default. The reason is the late can the late can turn out to be a good standing loan as well. After 1 month or 2 months, the customer might have forgotten to pay. There are multiple aspects that comes to him to pay. But fully paid, I exactly know the customer has paid off and the customer had a good standing. The charged off, I exactly know the customer account turned out to be a bad. The default, I know the customer has delayed behind some certain time and may definitely get charged off, or there may be some collection that might happen, right? So that's what I'm going to do. So what I'm doing is I'm creating a new data frame called loan intermediate data frame, and then I am populating with record which are not current, not late, not in grace, and again not late 16 to 30 days. That's what I'm doing. So this will contain only default loan, charged off, and if you see the output, you'll come to know. So now it has only the fully paid, charged off, and default. Right, and I can quickly say by the loan status what is my mean of what is my average FICO range. Right, that's what I'm going to do. So basically, if you see in the charged off bucket, my FICO range is usually average 564. By the default, it's 591, but in the fully paid, it's 705. So you can see basically the high FICO score customers are typically pay off, whereas like little less FICO score customer, there's high probability of charge off. So this is just to get an overall understanding, but it may not be true that every customer has a low FICO score will really charge off. Right, that may be, this is just a average. Right, so let's go into details and see how it looks like. Now what I'm going to do is I'm going to change my target column name. Wherever there is a charged off status, I'm going to make it default, and the fully paid, I'm going to make it good. That's what I'm going to do over here. So let me run this quickly and again do a value counts. I'm just renaming the target variable. So I have now two targets over here: good, the account that has been good in good standing, and then the account that has defaulted. Right, that's these are the two variables. Let me quickly print the info to check the different columns and data types. I'll not go into the details of it. Like a lot of things are int and float, some are object. Wherever there is an categorical value, you can find it object. Otherwise, it's going to be int and float. Now, coming to the FICO range, right? Let me print the minimum and maximum value of the FICO range. So the minimum value is 660 and the maximum value is 845. So this is the time at the this is the data at the time the loan was written. This is the FICO range low. So basically, Lending Club has written only customers, underwritten only customers who have at least 660 credit score, and the maximum is 845. The maximum is typically 850, but I'm taking the lower range. So I'm taking the FICO range low. If I take the high, I will get 850. So maximum range is also there. Right now, let me check the last FICO range low. The reason is, what is happening, the last FICO range is after the loan has been taken, the customer payment behavior might change. So his FICO range might change continuously, right? And in a credit risk modeling, those the parameters you validate and then you run an simulation on the customer if the customer can become risky, right? So let me run this low value, and you can see the low value is 0 because what has happened for some of the customer, it is not captured. So we will handle it, right? What we are going to do is, in the last FICO range low value, I'm going to apply a lambda function, and the lambda function is, if this low value is 0 over here, right, then I am going to use the FICO range low variable. Else I am going to use the last FICO range row itself. So basically what I am telling is, for my analysis, I am going to use the last FICO range row, but since it's 0, I am going to take the FICO range low value itself when it was underwritten. Wherever it's non-zero, I'm going to use this value directly. So that's what I'm doing. I'm applying a lambda function over here. So let me run this, and then I'm going to print the minimum and maximum value of the FICO range row. So while this is running, let me run the other two as well, minimum and maximum. So this should be done. So now in the minimum is 500. So basically, as I said, 650 is an typically customer, like typically the customers who will be have good credit history. That's what typically a bank thinks like. 500 is typically a subprime customer. So this, there are some subprime customers also, or this customer were good but they kind of turned out to be risky, right? And then the maximum is 845 FICO score. So now next what I'm going to do is, I am going to take the FICO score variable, right? Now the FICO score is continuous variable. It can be 503, 504, 505. I'm going to bucket it into deciles, rather deciles, by bucket it into the nearest 10th digit. The reason I want to do is, when I'm creating my target value, I don't want too much of data. I just want FICO score. If it's 500 to 845, I just need 500, 510, 520, 530, and within that I want to summarize the value, right? So what I'm doing is, I'm importing the math function. I am creating a new variable called FICO score over here. And then I am taking the last FICO score. I'm applying a lambda function. I am doing a math.ceil of the incoming variable X, that is the FICO range low, divide by 10. So if the FICO range is 845, when I do a divide by 10, I get 84 to 84.5. And the 84.5, when I convert to int, will become 84. And then I'm doing a multiplied by 10, right? Sorry, because I'm doing a ceil, it will show me 85, because when I do an 84.5, math.ceil will convert it to a higher ceil value. So it's going to show like basically 85, and then I'm going to convert to int, and then I'm going to multiply by 10. So that's what I'm doing it over here. So let me run this value, and let me show you the output for you to get a better understanding. So this is some value. What I've done is, I've created a new FICO score variable. If the low value is 560, right? Because it's already rounded to the 10th value, it's 560. But if it's 695, it will become 700. If it becomes 700, it's 700. So the thing I have done is, I have just made it to the next 10th value rather than having the intermediate 5 value, so that I am having less buckets to summarize. And I'm going to create a data set with this value, which will have like some rows where I can do a lot of statistical inference out of it, right? So now let me quickly go and check the null value in this table, right? Null value in this particular data set. Now the employee title is null, but we are not going to use the employee title for now. We are going to use the DTI column. There are 218 null values, right? So we have to fix that. Now, I remember I told you the DTI is the debt to income ratio, but when there's a joint account, right? DTI joint, that means the application type is joint, then the DTA joint will have the value, not the DTA column will have the value. So that's what I'm going to do next. I'm going to go and quickly check the null values in the DTA column, right? Let me quickly check this. And you see, like whenever there is an null value in the DTA column, if you see over here, the DTA column is null value. And if you go to the application type of all of this, it's going to show you an joint application. And the application type is joint application, and the DTI joint column is basically populated, right? So what I need to do is I'm going to again go and apply an lambda function. I'm creating a new variable called DTA underscore final, and I am telling that if the DTA column is null, then take the DTA joint, else take the DTI. Right, so basically it's a joint application, it's null, so you take the DTA joint. And I'm doing the same thing for the annual income as well, because the annual income will be 0 if it's a joint application, but the annual income joint will have a value, and I'm assigning it to the annual income final. So let me quickly run these two variables as well, and then again after this is run, I am going to quickly check the null values again. Right, I'm going to take some of these values and create a final data set, which will be small, which will be well summarized, and which we can use for our statistical analysis, right? Since the data is around 1 million, all this lambda function is taking time. But if you use any other function like replace or something like that, it will take ages. So lambda function is a good way of speeding up your process. Now the function is run. Now let me summarize the data again. You can see the DTA final that we are going to use does not have any null value. The annual income does not have any null value. The FICO score does not have any null value. So we have created kind of a data set that is pretty clean now. Let me quickly summarize the data set. Let me quickly check the first few rows, and you can see like we have some additional columns that is getting created. And here you can see the DTA joint value is there, and basically just a minute. Yeah, so in this case the DTA is null, so we are taking the joint value over here, right? So that's what we are doing. And I'm going to do is I'm going to create a new data frame over here. And in the data frame, I'm going to kind of run the FICO score distribution. So let me do one thing. Let me run this and show it to you, and so that you know what exactly is in the what exactly is going into the database, right? So I'm going to take this. I'm going to do a value count. I'm going to sort based on the index. So when I do that, it will show all the different FICO scores and the number of values that are there in the FICO score. So in this case, 500 FICO score has 3585 value, 510. Remember, we kind of shortened it to the 10th bucket, right? So that's why you have only 10th value over here. So it's showing the distribution of data, and that's what I'm doing. I'm creating my data frame with this particular value. So let me quickly run this, and if you see the FICO.head, you can see this value, right? This is one data that I'm going to populate. The second data I'm going to populate it, I am going to take wherever the load status is default, right, from the data frame, and I am going to again do the value counts of the FICO score. So this is for all customers, whether the customer is good or customer is defaulted, but I want only default value. And I'm going to do a value counts and then sort index. So you can see the output now. This is how it will look like. In this case, only the defaulted customer. So for example, in 500, there are 3181 customer who are defaulted out of 3585. That is a pretty huge number, right? So I'm creating a default. I'm just running it and show it to you, but I'm going to concatenate all of this into a single data frame. Next, I am taking my FICO score again. I am creating a mean of my annual income and interest rate. That is the, before that I have one more. So next what I'm doing is I'm taking my FICO score. I am creating the DTI final, loan amount and annual income. I am grouping by FICO score again. As I told you, all the summaries I am creating is on FICO score, because FICO score is a key variable for credit underwriting. So I want to kind of segment by customer based on FICO score, right? So in this case, what I'm doing is I'm creating aggregation. On the debt to income ratio final column, I'm creating an average, mean value. On loan amount, I'm creating a mean value. And on annual income, I'm creating a median value. So for the income, I'm using a median value. So that's what I'm doing over here. Now, if you see over here, again, three columns will be created with each FICO score bucket, loan amount, TTF final, and annual income. And then I'm going to create furthermore metrics. So these are all metrics. These are all business metrics to measure your loan performance. That's what I'm doing over here. Next, I'm again going to take an annual income and interest rate, and I am going to create an average of it, mean of it, right? In the previous annual income, I created median. Now in this, I'm creating mean. So I'm just running it now. Once I have all this, what I'm doing is I'm again going to the FICO data frame. I am concatenating all the above data that I created. So I have the FICO DF itself. Then I am doing that loan amount, default status, FICO score, value counts. Then again I am converting the another function to a data frame. All of these are converted into an data frame, and I'm attaching into a single data frame. Once I run it, you can see it. So let me do an add now. Now you see basically I have the FICO score. This is my total loan count. This is my default loan count, and this may be interest rate. So all these are different there, but the column does not have any name. So what I'm going to do is, very first thing, before giving the name to the column, I'm going to reset my index, because when I'm concatenating, I have every column is grouped by FICO. So FICO is acting as an index. I'm going to reset the index so the FICO score becomes a column, and then I am giving a column name, FICO score, loan amount, default, for all of the 0 and 1, so that it's more readable, right? Let me now run the output. So you can see basically I've created a data set which is having a summarized metric based on the FICO score. It has various metrics like what is the average debt to income ratio, what is the average loan amount, what is the median annual income, what is the average annual income. Now with this, I'm going to create few more metrics, two more metrics, right? So I'm going to create something called default rate, and for the default rate, what I'm taking is I'm taking the default total for each row, and then dividing it by the total of this particular row. So it's 3183 by sum of this particular row. And the second thing I'm telling is actual default rate. The actual default rate is again default rate, but rather than dividing it by this total, I'm dividing it by loan and total. So I'm just trying to find out of all the loan, how much is the default. Out of the default total, what is the default in each bucket? That's what I'm trying to do in this thing. So let me run this too, and let me print the first 20 records of the data frame. And now our data frame is ready. You can see this, all this value is there, and you have the default rate and actual default rate which we added, right? Now let me quickly describe the statistics of this particular column, and why I have created this data set, right? See, when we talk about statistical function, if you see an typically any statistics video, they take some random x and y value that are handmade, and then they show it. It does not tie it to a real business process. And here I am trying to create it from a real data set, and then I'm going to see like how most of my statistical functions can be applied, right? So if you see, this is the distribution of the data. I will go into the more details in the next video. I'll quickly get the correlation, Pearson correlation of this particular data set. And if you see over here, I have data with a good strong negative correlation, strong positive correlation, no correlation, and some may be like kind of some can be and good linear data, some can be a non-linear data, some can be monotonic relationship. I'm going to show that more about the relationship in the data one by one. But I got a data set now which is pretty much ready for us to use for other statistical analysis. And what I'm going to do is I'm going to take this FICO DF, I'm going to kind of convert it to a CSV file and save it. I'll also put it in my GitHub repo if you want to use this for your video. If you want to run the entire notebook, you can download from Kaggle and run it. It's 1.3 GB. You can download from there. I don't want to share such big data set. But this data set I'm going to show it. If you want to just watch the video and not run it and directly go to my next video that I'll be creating, you can use that data frame. So that's about it in this video. We will take this and do a lot of analysis, and also we will learn statistics in the process. Thank you very much.